好，那 so good afternoon, and let me admit our classmates in. Last week we covered sample problem 2.1 and 2.2. In sample problem 2.1 and 2.2, that we only deal with addition of forces as factors. In the course of doing calculations, I'm confident about your mathematics. So we always use law of sines or law of cosine, these things to do our calculation. I strongly recommend you to draw figures before doing calculations. Please draw figures before doing calculations, okay? Before the end of the class on Thursday, we began discussing how to break down a force into two, making one force into two forces. As we all know that there are infinite number of combinations exist for breaking down one force into two forces. On the textbook, it says the resolution of a force into components, but you can think about it as breaking down a force into two, okay? Two cases are of particular interest. One is either P or Q is known. If we know Q and we know P plus Q equals F, so we can get P. The other case is we don't know about P, we don't know about Q either, but we know the directions of P and direction of Q, and then we use our law of sines, law of cosines, these things, you must know them to calculate the magnitudes of P and Q. Magnitudes is this one. So that's we ended there last Thursday. We move on today. We move on by redoing problem 2.1. We move on by redoing problem 2.1 by the new concepts we learned last Thursday. We have P equals to 14 newtons. Let me draw it shorter. We have P here. We have P here, 14 newtons. And then we have Q 16 newtons here. Let me draw it here. Let me put it there. And we want to add these two forces together, and we have this. This is 20 degrees, and this is 25 degrees. Of course, I don't draw it very well, but you know what I'm talking about. Should I make it a bit better here? Yeah. Okay, a bit better now. We want to. What are we calculating in problem 2.1? Can anybody remind me? You can, of course, you can say in Chinese. What are we determining in problem 2.1? Anybody?
Resultants.
Resultants, very good. Very good. So we are determining the resultant of these two forces. So we are determining the resultants R. Now we do it in a different way. Last time we did it using triangles. This time we are doing by breaking down Q into two parts. We break down Q into two parts. One part is parallel to P. We call it Q parallel, and another part is Q perpendicular. Of course, these two are perpendicular to each other. Perpendicular is this one, and parallel is this one. Of course, if we are determining R, it equals to P plus Q, and in theory, by the figure, you know that it is equals to P plus Q parallel plus Q perpendicular. Is there any problem with this logic? I think you should be okay. So we want to do P plus Q, but of course we break down or we resolve Q into these two. This is Q parallel and Q perpendicular, and we will have these three. Of course, we arrived originally these two forces are separated like this, and now we want to do calculations like this, right? Can we do this? I think we can. So let's go on. So let's do it this way, and we break it down into these two parts, and we go on. Let's try. For this Q parallel, it is equal to 60 times cosine 25 degrees. It is equal to 54.38 Newton. So remember 1, 2, 3, 4. 1, 2, 3, 4, 4 figures here. Another one is Q perpendicular. Its magnitude is 60 times sine 25 degrees, which is equal to 25.36 Newton. And for this R, for the magnitude of resultant, it is easy to do it because these two are of the same, in the same direction, right? These P and Q parallel are along the same direction. So this 40, if we want to find the resultant of this part and this part, we simply add them together. We add 40 plus the magnitude of this Q parallel. And of course, we know these two this part P plus Q parallel is perpendicular to Q perpendicular. So the magnitude of R is equal to the square root of the sums, and I think you know if you can't understand that, at least you will know when I write it down. Q. I think you can record this, right? I think you can record this because this part is this part, and this part is this part. So this we want to determine the magnitude of this side, that because this is a right angle triangle, we simply add the sum, the square of the sum, and then the square of this one, and then we take the square root. You know what a square root is, right? Square root of the sum. So if we know it is equal to 97.73 Newton, and for this angle because for forces we need to determine the magnitude and we also need to determine the angle alpha. So for alpha, of course, we know tangent alpha is equal to 25.36 over 97. 94.38. So alpha equals to 15.04 degrees. So R is equal to 97.73 Newton. Angle 35.04 degrees. So this is our result. Take a look and write down the key points. And if you are fine that and finish copying, raise your hand and let me know. Thank you. Let me have a tea first. And let me check if there are any classmates who cannot get into the classroom. Okay, most of you, it seems, yeah, through one mini crisis. Good. But the others okay. Should I give you 1 or 2 minutes more? I suppose does anybody want to see the figure here? No. I think you can. I assume most of you are fine. All right. I will let you write it, copy this during the break, or you. So the others are the others on in the meeting. At any time when I want to go on, when I want to continue, you can just say, wait a minute, then I will wait for you. Okay. So I suppose most of you are okay, or should I wait? So I can't see anybody. So I don't see anybody who wants me to wait at the moment. Then I will go on. We come to the next topic on page 9. Page 9, unit vector. Unit vector is in China. Of course, this is also a new word, and but in Chinese you should have met it. It means this one. And before talking about this unit vector, let's revise some very basic things. Does anybody know what is does anybody know the Chinese of this one? I think you should have learned it at high school. Okay, you may lower your hands. Thank you. You may lower your hands. Does anybody know what is this one in Chinese? You can either say it or write it down on the chat box. Does anybody know? Okay. XYZ. Yes, XYZ, but I think you know the word in. Okay, so good, and I see some comments that and of course if you write it formally, it is this one. But of course, I don't know. But I mean, in the past, I only know from the others that sometimes I think some high school teachers would say this one, right? And of course, that another among us said it is XYZ. Very good. Let us talk about 2D first. And let's talk about 2D first. And we have fx and f. We have x direction and y direction. X and y directions, and we have a vector f. We have a vector f here. We can break it down into two parts. We can break it down in two parts and treat it as the sum of two vectors. One is fx, and one is fy. I assume you know how to calculate these two parts. I assume you know how to calculate these two parts, and f is equals to fx plus fy, and fx is equal to f cosine theta, and fy equals to f sine theta. If this is theta, I assume you know this one. I assume you know this one. And we want to for Cartesian coordinates. We have Cartesian coordinates. We have this one, and the next part is we want to because we have fx as vector and fx and fy as vectors here, and we have the magnitudes as scalar. These two are scalars, right? Scalar, and these two are vectors. We want to find a way to link these two groups, fy scalars, fx, fy as vectors. We want to link them. we want to link the scalar quantities and the vector quantities. Therefore, we have something called unit vectors, and the Chinese for unit vector is here. How do we define unit vectors? Unit vectors. It means the magnitude is equal to 1, okay? Unit vectors are the vectors with magnitude equals to 1. We will deal with many unit vectors in the coming weeks, but we have 2 unit vectors we want to talk about it now. So one of them is along the x direction, and another of them is along the y direction. For the one along x direction and for the y direction, we want to assume these two are of length equal to 1. This one is called, of course, this one is called I, and this one is called J. In this course, I use these two. We use heads to mark unit vectors. If you write I or J, it is okay. It's okay that you use normal vector notation, but in my writing, I would use heads. I think your calculus teacher may have different opinion, or may have different standards. But in my course in statics, you can write it as heads or you can write it as vectors. Either is okay. Therefore, if we have these 2 unit vectors, because they have directions, but their magnitudes are equal to 1. They have directions. One is along x direction, one is along y direction, but their magnitude is equal to 1. Therefore, f is equal to fxi plus fyj, and of course this one equals to fx, and this one is equal to fy. I assume you know the concepts before, right? Concepts is right. You know this before, right? If you have seen all of these, of course in Chinese, please, or you have seen them in English, please raise your hand and let me know. If you have seen this, I and J, these things, and the magnitudes are equal to 1, please raise your hand and let me know. Good. Okay, then I will. Yeah, you can lower your hands now. Thank you very much. I'm just thinking how should we do? Should we ask you to raise your hand when we see you in the classroom? But let's do it. Let's see what happens next week. Okay, we come to an example. A force of 800 newtons is exerted on both A as shown. I think we covered these words, right? Exerted on both. Determine the horizontal and vertical components of the force. Horizontal is this one, And vertical is this one. It is not perpendicular because vertical means this one, up and down. Components means this one. It's okay. It depends on how you say it. You can use this one or this one. So remember, we have for this one. Of course, this is not a difficult question. We have let's draw a figure on this. This is not a difficult question, and of course we have x and we have y. Remember, if you use I and j, you stick to x is towards the right and y is going upwards. X going towards the right and y going upwards. And we have this 800 newtons going here. And we have, of course, in the example you are given this 35 degrees. You are given. Sometimes we would say just given. I would say you are given. That means we know that this 35 degrees, but if we use xy coordinates, if we use x towards the right as positive, y and upward as positive, we cannot use this 100 and we cannot use this 35 degrees directly. We have to determine this angle. This angle is 145 degrees. Therefore, fx is equal to 800 times cosine 145 degrees equal to minus 6 is equal to this one. Fy equals to 800 times sine 145 degrees equal to this one. Therefore, because the answer is asking you to determine the components, of course you can, I cannot say you are wrong if you stop here. If you stop here, I cannot say you are wrong. But let me complete the answer by rewriting the force like this. Newton. This is our answer. If you have finished reading or finished copying it, you can raise your hand and let me know. Take your time. I'll give you time. Okay, and anyone having problems or you want more time? Of course, when you ask questions or you answer my questions, you can always use Chinese, and if you can use Chinese if you want. So okay, give me free. So I assume you are all right. Anybody want some more time to copy these down or write them down? Give me 3 more minutes, and I'll have a break. Okay, give me 3 more minutes, and you can lower your hands. Thank you. You can lower your hands. Thank you. Page 10 is I take some words. I take I copy one page from the textbook, and this from the textbook. This is and of course in this course we are when you come to university that you are dealing with much English, both my spoken English and the English on textbook because I think you have English. You have English ones, the calculus one, the statics one, I think the physics one as well. So I know it is a hard time reading your textbook. I know it is not easy. Let's see. But my first advice to read the English textbook is to chop it down into small pieces. Make it into small pieces. Let's see. For example, on this page, we have a whole page of English on in words. There are no figures. There are only 1 or 2 equations. Most of them are words. But you can always chop them down into pieces. For example, let's come to the first for the second sentence here. From this law to other methods, like this one. This one is a very long sentence. But let's see. We have this one. We have a pretty long. We have this one is wait a minute. Squeeze between 2 commas or to how you do this, because in British English, in UK English, these are called commas. And so in English, when you study English, you know that usually these things between 2 commas are usually which will start with which, where, or something similar. These are only for describing this one. These are not necessary. You can skip these ones. You can skip this. You can skip this at the first when you first read it. For example, you can first skip that when you first read it. This is the first thing. This is the first thing. So you need to read less. I'll explain it again after the recording. Okay. The second thing we have is the last paragraph. The last paragraph is quite long, right? How many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines, and it is very difficult. But Also, remember my rule, chop it down into small pieces. And let's see, we have these words finally, and we have first. So when you read the paragraph, it says it is in 3 steps. In 3 steps, what is in 3 steps? 3 steps is this one, right? So with 3 steps, you have the first step, you have the second step, you have the first step, step 1, step 2, step 3, or first step, second step, first step. It is up to you how to say it. So we have the first step, and then we go on. You go on first step, and this is the one sentence. One sentence, right? One sentence, and then we have another sentence, and then we have the last. Finally, it's the last step, right? The last step. So the second step would be, I think the second step will be here, and then this one is the first step, right? And then it comes to here. So you are now you can have a better picture of what they are saying, and you don't need to read 10 lines at once. Is that okay? Let's stop the recording, and